This is the Nikon SLM Expert Talk. The subject of today's episode is productivity in additive manufacturing, where we talk about different laser spot sizes and beam shaping. This episode is hosted by Benjamin Haas, and our guests are Kenan Yittel, Tim Over, and Peter Dacus.
All right, welcome guys. Thank you for joining me. My name is Benjamin, Product Marketing Manager at Nikon SLM Solutions. And today I really want to talk about productivity. I think we've got a very collective mix of people here. So Kenan, maybe you can explain what you do, who you are, and what kind of tasks you're working on at Nikon SLM Solutions.
Hi Benjamin. Hey guys, thanks for having us here. I'm Kenan Yittel. I'm a senior development engineer at Nikon SLM Solutions. I've been working on novel laser sources, scanners and optics and their integrations to our machines. And of course, the feasibilities on a system level. On the other hand, I do a bit of material parameter development as a means of proof of concepts of all of these technologies that we are trying to develop over here.
Very good. Welcome.
Thank you.
Tim.
Yeah, hi Benjamin, I'm Tim. I'm a senior development engineer as well at Future Technologies. I've been in science before. I joined here the company about 2 years ago and really look into the laser and optics topic here, so also about beam shaping, what helps us to drive productivity in this respect.
So Future Technologies, I mean, what do you guys do? That sounds very interesting.
Yeah, as the name already says, it's about what could be the future machine applications, future components, but also entire machines that can be developed for the next generation of machines. And then it goes into real product developments, part of it, and so it's kind of pre-production.
So are you already allowed to share a few insights into what you do, or is it all top secret?
And mostly it's top secret, of course, but we have a lab downstairs here, and we have been investigating new technologies. We are trying to make sure that they are compatible with our technology. And of course, all of the technologies that we develop over here, they will be transferred to the new products, and then hopefully will become part of customers' portfolio.
Excellent. So before we dive deeper into the topic of productivity, last but not least, Peter.
Hi, I'm Peter Dacus, a senior laser and optics systems engineer in the laser and optics group. We integrate the lasers, optics and calibration processes on our machines in the next generation and current products inside Nikon.
Okay, great. So quite a collective group of people here today with very sophisticated skills, and I'll try my best to keep up with you guys. So if you think about productivity in metal AM or metal additive manufacturing, what's your current take on the whole topic of productivity?
Yeah, speed, power, productivity, everyone talks about them. But sometimes it's worth to pause and look back at what's really happening. In a young technology like ours, new hypes appear every few years. And that's a good thing. We have seen them all. We've been in the early 2000s in the lead of developing the first quad laser system, the SLM 500. And more recently, we have done the new generation NXG machines, which boost really in productivity. And this is all for turning the hype into real sustainable productivity. Mm-hmm.
Now as more industries integrate additive manufacturing into production, the focus really shifts into the business cases, because AM only really pays off when you use it to its full potential. When every improvement in productivity, safety and quality turns directly into manufacturing value.
I couldn't agree more, and I think that's really where the industry needs to move in order to get fully integrated. I mean, just a few years ago, customers were approaching us without any business case in mind, with no application in mind. They just wanted to play with the technology. So I think it's certainly a good thing to happen. And it's also a good thing that there are lots of new trends coming up every other year. So lately, I think beam shaping has been a very important buzzword. So what's your take on beam shaping?
Beam shaping is exciting, no questions. It's a fresh twist on how we control the laser in the additive manufacturing, but we have to also keep the perspective here Beam shaping has been around for many years for laser welding, long before the additive manufacturing actually adopted it.
Traditionally, AM uses a Gaussian beam, a single mode laser with the smallest possible spot. Beam shaping allows you to switch between Gaussians and other shapes. Due to the variable directions of the tracks that we're printing, potentially switching between a Gaussian or a ring mode or maybe something in between the two might be preferred. It's along the lines of painting with a fine brush or a really large brush depending on your application.
And we are already offering beam shaping in the 280 dual machine since 2011. So this machine is equipped next to a standard Gaussian laser, also with a multi-mode laser with 1000 watt. I mean, 1000 watt, that's really a new power regime in 2011. And we not only supply the hardware, but we also came up with a new scan strategy of core hull. So where you have the flat top mode in the core of the parts, and then in the hull structure you can have this finer Gaussian mode.
So it looks like beam shaping, as you said, is not new by any means, and we've been doing this for over a decade now. So what's really the practical value of beam shaping?
So the practical value is essentially increasing the laser power so that you can have more productivity out of your system. I actually brought a illustration that we can discuss here even. You can see here on the left-hand side the Gaussian beam and the right-hand side the shape beam. So basically, if you just crank up your power when you have a very focused Gaussian beam, you will end up having this keyhole, and then you will induce keyhole instabilities and you will end up having porous parts. But if you can actually have shallower melt pools, you can put potentially more laser power into your system, and then you can increase your productivity. So that's basically all it's about. But of course, beam shaping is not the only method to achieve that.
And I think that also your point makes sense, right? Because if you can introduce more power, therefore get higher productivity, then the whole business case discussion makes perfect sense.
Absolutely, yeah. Yeah, the faster you can build, potentially using high powers, the more likelihood you are to meet the customer's KPIs.
So how does Nikon SLM Solutions handle this differently?
You know, more than 15 years ago, we put flexibility directly into our optics, mechanically. While others were searching for tricks, we were shaping the light directly through zoom and defocus, which we'll present here.
So yeah, as Tim said, on the left-hand side here, we've got a 2D scanner, and this is a representation of how a standard AM machine might work. You have the X and Y scanned with the galvos, and you've got an F theta lens there doing the focus, changing the spot size and ensuring that it's the same everywhere around the powder bed. When we move to a 3-axis scanner, we do that focusing around the powder bed. Rather than with an F theta lens, we do it with a moving optic. When we move to zoom and a 4D axis, effectively, we're also changing the beam size and keeping it in focus. Now, the reason that we might be comparing beam shaping to this system is we're effectively already beam shaping, but with changing that Gaussian spot, and we don't need to introduce a different kind of beam to do that.
So why would anyone still use an F theta lens then?
It's cheaper and easier to integrate. The other one, you have an additional motor, additional electronics, but it enables more functionality.
So if you were to compare them, F theta, basically how the selective laser melting process started years ago, and the 3D optics then would already be something a little bit more sophisticated, but it gives you that extra advantage, and you don't need to switch the laser source, but you can use existing lasers and already be more productive.
Yeah, exactly that. Like Tim said, with the F theta lens, you're there with a simpler system, achieving the bare minimum. With the 3-4 axis systems, you're making the system more complex, yes, but you're opening that processing window. You're able to do more with them, vary the beam quickly, and really tailor it to what you're trying to do in the build part.
That's why I think beam shaping was revolutionary for the systems that have 2D axis scanners. Mm-hmm. But on the other hand, if you already have 3D axis scanners, you can actually change your beam size however you wish. So that's the main point here.
That makes a lot of sense. And essentially that would also mean that the 4D optics we have with the zoom optics, is that like the most sophisticated optic system out in the market right now?
Yes, of course. They are currently the most sophisticated ones. And if we can actually combine beam shaping with the zoom optics, then that's the real value will come. And then we will unleash the full potential of beam shaping here.
And that's great because we don't have to re-qualify the whole optic system yet because we've been using 4D optics for over 5 years now. So essentially we're just switching the laser source to a beam shaping laser and already have an optic system that's way ahead of f-theta lenses.
And at this point, maybe I would like to also show a graph that can be very useful to understand. So here you can see also the cost per parts and the output rates comparing 2D, 3D and 4D optics. And if you can see here, our zoom optics are still the fastest in the market. And the 2D optics combined with beam shaping is just catching up our defocusing parameters. And of course here the next step is basically combining the zoom with the beam shaping. So there's actually yet another great chart that I can also show. So here on the left, on this graph, you can see the power versus beam sizes and different intensity values demonstrating different welding modes. So the red lines you can see, they are the 2D optics beam sizes and 2D optics combined with beam shaping. As you can see in that lines, when you use high powers, you are already in the keyhole mode. So the moment you actually start zooming your beam, you can already achieve all of these conduction and transition modes, and you can have a broader control over your process. And if you combine the zoom optics with the beam shaping, you will unlock the entire different process window so that you can actually tailor your welding modes to your process.
So already by using a zoom optic, I can increase my beam size up to 500 micrometer compared to roughly 100 that I can do with 2D optics?
Exactly. You can change your beam size between 80 micron up until 0.5 millimeter using the zoom optics.
So already a factor of 5?
Already a factor of 5, that's true. And of course, this is something proven, this is already produced, and the customers are using it as we speak, right? So that's very important to highlight.
Yeah. I mean, the NXG has been, what, 5-6 years in the market now? So as this whole technology more and more matures, of course, it's also important to qualify everything. So how do you qualify production readiness for these kind of optical systems?
We qualify every new laser and optical scanner type in the lab, assessing their stability, whether it's thermal, optical characteristics, or just general performance. And then we ensure that that laser or optic meets all the requirements that we have for the system, the machine. We then would take them onto machine and ensure that they again meet all those characteristics through some development platform. Once we have qualified everything, we have incoming goods inspection for lasers, for scanners, and we use those as baselines when we put them onto a machine. And finally do our optical calibrations, making sure that that machine is in spec. In the field, the service engineers, or in some cases even the customers themselves, make sure that when they're doing verification or calibration, they will have that machine kept in spec as well.
Yeah, and I mean, that makes perfect sense, right? I mean, lasers are one of the most, if not the most important ingredient in our machines. So of course we want to treat them properly and make sure they're fully qualified, also in serious production. So compared to competitors who are introducing beam shaping today, what's the difference in real terms? And does that mean that Nikon SLM Solutions is already done with beam shaping research?
Not at all. So we've been talking about theory, but let's take a look at a real experiment that we did here in our lab, which is that we have an SLM 500 machine equipped with all types of beam shaping and different types of optics, what we just explained, the 3D optics and also to 4D or zoom optics. And with this system, we've done one exemplary study where we compare defocus and ring beam, and here you see the results.
Yes, so this is basically a very small portion of a very extensive tests that we have carried out. You can see different laser beam shapes and their defocusing counterparts. Their beam sizes, they're all the same. And when you look at the index 0, aka the Gaussian mode, when we actually crank up the laser power, we ended up having very porous parts. But the moment we increase the beam size, regardless of the shape itself, we start having very dense parts. So that actually proves that there are multiple ways of enlarging the beam so that we can have more stable processes.
And our customers have been using this optical approach for over a decade, long before the term beam shaping even popped up. And while others try to do tricks with the laser shape, we already achieve these high productivity levels. And that's why our customers like Saab, Bosch or Lockheed Martin use our NXG series to get to real high productivities.
Do you have an example of true high productivity?
Yes, we have an in-house example here where we reached more than 1,000 cubic centimeters per hour with this NXG system as a demonstration. We built this big 1,000 here.
And that's real build rate, not theoretical build rate.
That's exactly the real build rate over all lasers, bringing together also the interlayer time and everything. And still the value was over 1,000 cubic centimeters, where others mostly talk about theoretical build rate per laser.
Yeah, and if you do the math on ALSI 10 mg, I mean, this would give you, what, like 3.2 kilograms of aluminum per hour?
Yes, exactly. It's over 3 kilograms per hour. We can also have this on other compounds, but for aluminum we have this product parameter released so that our customer can use it.
Perfect. So I think this was 120 or 100 micrometer layer thickness.
Exactly, that was 120 micrometer layer thickness. That's called the productivity plus parameters, and then we have tunable parameters depending on the precision and the productivity that the customers want. So we have productivity parameters from 30, 60, 90 and 120 micron layer thickness.
And these productivity plus parameters are also valid for titanium and many more to come, of course.
I think this is interesting. If you use it on Ti-64, which is a material that's quite prone to residual stresses and sometimes even cracking, I think that's probably quite a challenge also for the system in terms of keeping it thermally stable to make sure that parts don't crack during the build.
Exactly, that's where the beauty of NXG systems come, because they beautifully handle all of these laser power with their very advanced gas flows in the system.
So beyond laser performance, what else do people commonly overlook when it comes to productivity?
Productivity only starts with laser power. What matters here is that laser power per build area. Our NXGs are clearly in the lead in this requirement. For the NXG, we have a power density of more than 3 watts per centimeter squared. Moreover, this power and power density also has to be handled in terms of the optical and thermal stability in the machine. It's not enough to release a machine with such power density without having it safe and reliable to do so.
So if you had to sum up Nikon SLM Solutions' position on productivity, what would that be?
Well, from the first quad lasers to the NXGs, we've redefined what productivity means in additive manufacturing. Our systems deliver output others need new modes to reach. Basically, they do it with proven reliability. We've been in the spot business for over a decade and we're still leading it, because precision isn't just about chasing trends, but it's about mastering focus. And that's what Nikon SLM Solutions has done consistently for over 15 years.
So I think we can summarize it as follows. So there are different ways of achieving high productivity, and I think Nikon SLM Solutions has been on quite a good track for over, the past decade now, to come up with solutions that really get productivity to a maximum level and in the end enable business cases, as you said in the very beginning. So thank you all for your time. I think it was an excellent discussion.
Thank you for having us.
Thank you.
Thank you.
Thank you.